Hello everyone, welcome to the video recording part 1 of online Zoom session.
Hello everyone, welcome to online session on project transformation, value improvement with Joe Essenburg. The session is organized by Project Professional, which organizes such sessions regularly. Everyone please mute your mic so that we don't have any disturbance. You can unmute during the question and answer session. About Joe, he is from Stroud International and into this field for a long time. Now let us start session with Joe. Joe, the floor is open for you.
Great, thanks Tanvir. And like you mentioned, so for the Project Professional group today, we're going to focus on what it takes to transform a project in terms of its value. So just some background on myself and Stroud. And as people mute themselves, it's always fun when we've got so many people on these. So I'm a mechanical engineer. I'm a professional engineer by training. I've gotten my master's from MIT, and prior to that had a bachelor's in engineering, physics, and math. And earlier on in my career, I worked as a researcher in the aerospace sector, working with NASA. Here, let's see if I have the ability to do that. I don't know if I can mute all the participants. But anyway, like I said, earlier on in my career, I worked as a researcher with NASA, the U.S. Air Force, and National Space Biomedical Research Lab. And as much as I love research, I have great respect for researchers. What really drove me into consulting was a desire to solve problems on a quicker time frame. Research time frames are usually roughly 5 years or a decade out, which is essential, but I like making results and an impact very quickly. So that's why I transitioned over into consulting, and I joined Stroud in 2008. And now I'm based in Calgary. At Stroud, I co-lead the global capital projects practice, and I manage our operations in Canada. And as far as who Stroud is, we are a professional services firm. We specialize in driving breakthrough improvement in capital projects operations. And when we talk about breakthrough improvements for a capital project, the sort of results we're going to be talking about today are a 30 to 60% improvement in cost and schedule without trade-offs. Conversely, we also have an operations practice that provides the same tools in terms of eliminating capacity, cost, quality problems. And the focus of doing these is how do you not only achieve results like that, but do it in the order of 10 weeks or less. So that's the background. I'm going to go through the material relatively quickly, and then we're going to have a question and discussion. So I'm just going to plow through and then ask for questions later. But all right. So as far as project transformation, let me see if I can get rid of that. There we go. Oh, I've got a menu in the way on mine. But when we talk about project transformation, how this level of improvement is possible, what we're going to cover is basically what's the problem. There's 5 cultural barriers preventing projects from reaching their full potential. We're going to talk about where these impact projects, how they might impact you working on them, and then what we can do about it. And so to set some context here, I'm going to talk about major projects in the context of many decisions being made over time. And so on a project, you have a large team of specialist roles. You follow a highly structured process. There's loads of best practice. We're all familiar for that. But when you're in conceptual design, typically a project team is a handful of people, maybe 10, that make a handful of decisions on concept select. Then you get into design basis, and now all of a sudden you've got dozens of people, if not 50 or more, making hundreds of decisions. And then you go into detailed engineering. Now you've got multiple hundreds of people making thousands of decisions. And then into your execution, again, you've got potentially 2,000, 4,000 people on site, all executing, making decisions every day. And so then the question is, how can you make sure of those thousands of decisions that for the vast majority of them, they're driving the most value versus leaving value on the table? So to set the context also of when we talk about 30 to 60% improvement, what kind of upside is possible when you have improved decisions? So as an example here, I'm going to use the Liberty ship, which is dubbed the most repeated capital project of all time. For this is a ship from World War II, but it shows what's possible as decisions get better. So there were over 2,700 ships built between 1941 and 1945, quite a fast time frame to build that many. They were done across 18 shipyards, but one shipyard in particular called the Cal Shipyard made 366 of them, and they made the most of them. So the first ship cost $3.8 million. In today's dollars, that's much more, but back in 1941, that was a big number. So $3.8 million. It took 276 days, 3/4 of a year, and the ship lasted in service for 5 years. Then if you fast forward to the last ship the Cal Shipyard made, number 366, the picture looks quite a bit different. They were able to build the last ship for 30% less cost. They literally did it in 85% less time. Rather than 3/4 of a year, it took them a month and a half. And that last ship lasted twice as long, actually more than twice as long. So then the question is, basically, when CalShip was making their first ship, the potential upside that was in that last ship was still there. It just wasn't tapped yet. So then the question is, what if there was a way to get at this much earlier and not take 366 times to do it? So let's explore how that is and what prevents the level of value decision-making in the last ship from happening right away. So in the last ship, yeah, there was lots of experience, but at that point they knew, we know to design it this way, we know to tweak it this way because it's much easier to construct, we know it's much cheaper, we know it's going to last longer. How do we get at that the first time around on a project? So as far as what holds a project back, I'm going to talk about 5 barriers that are cultural barriers that keep the value from being realized, and then we'll talk about what to do about it. But this is based on Stroud's been working with capital projects basically for 15 years now. This data is taken from the 35 biggest projects we worked with from the oil, gas, and mining industries. And the 5 barriers, and just a reminder, if you could put yourself on mute, it'd be appreciated. But the first one, accepting false trade-offs, over-relying on benchmarks, dismissing ideas prematurely, waiting for another time, and then we're going to talk about some of the incentives to hide value. So I'm going to walk through a quick example of each of these, and then we'll open it up. But for the example, I'm going to use an upstream oil and gas well pad, just as the worked example, just because the design is straightforward enough that could be familiar to any of us. But it shows on a real project how these 5 barriers came up and what the team did about them. So on this particular project, it was an upstream oil and gas development. They were mature in their operation, and what they were looking to do was expand the development roughly triple. And a large part of that is what they called sustaining pads, which was building new well pads, and each well pad would hold anywhere between 10 and 20 sets of wells that would produce. And the sustaining pads were the biggest cost of the development because the central processing facility was already there. So it was a question of how do we develop these pads in the most cost-effective manner. So we're going to talk about the 5 barriers, but for background, the company that was partnered here, this was a super major. It was a senior operator. They were partway through their design basis on the sustaining pads. And at the time the exercise was performed, the development needed to improve the costs, otherwise it wasn't going to hit the hurdle IRR, and the investment would have gone elsewhere. So that's the context. The final result that we were able to drive this project was basically reducing the CapEx by 60%. And let's look what it took to do that. So for the first barrier, I talked about accepting false trade-offs. Here I'm going to hit at the concept we talked about in the Liberty ship, but I'm going to name it. Who's heard the concept good, fast, cheap, you can only pick 2. What that's called is called the iron triangle, or the project triangle, or the triple constraint. It's something I was taught as a project manager. And it's the idea that cost, quality, and schedule are kind of all the same. You know, they're different currencies, but they all represent value, and you can only get so much of each of them. And the challenge is a mindset like that leads you to believe once the design's set, there's no more low-hanging fruit, and there's an implicit assumption that, if we've made it this far in the design, it's as good as it's going to get. Anything else you want to do to it's going to have a trade-off. So if you want it quicker, fine, but it's going to cost more, and vice versa. So how do you get at this sort of mindset? And the example here, I'm just going to talk about with the well pad, the overall pad footprint is where this constraint came up. So on the well pad, this is what it looked like. There were some buildings, there was a central pipe rack, and then there were wells. On this particular development, they had injection wells and production wells. So I for injection, P for production. So when you look at the pad footprint and you start breaking it down, there's a number of decisions here that were made. Like, what's the spacing A? What's spacing B? What drives that? What's spacing C? And so for this example, I'm going to focus on spacing B. On the actual project, we looked at all these, but for spacing B, so then the question is, what drives spacing B? So there's a really good driver for it. You need emergency access, a completions rig, drilling rig 1 and drilling rig 2. It was basically driven by construction. For operations, you didn't need that much space, but for construction, you did. So then the question is, okay, how good could it be? What here could be improved to reduce the pad spacing theoretically? And then we'll leave at the construction contractors. There, you had the ability to reduce the spacing. There was no impact on the schedule, no impact on constructability, just straight up cost savings. And so that's the idea. There are trade-off-free savings there. In this case, they were able to reduce the distance by 40%. Overall, the pad footprint was able to be reduced over 60%. But that's an example there. So then the question is, how do you get at this on other projects? And it comes down to letting go of the idea that a design and execution need to be perfect. There's always going to be opportunity to improve it. It's never fully optimized. So, and when you're doing evaluations, like project teams I partner with, we don't do trade-off studies. There's no such thing, because that implies there must be a trade-off. We do value improvement studies or value improvement in evaluations, and it's just a mindset shift. And take note of what's your gut reaction if someone challenges your project design. Do you defend it, or do you, hey, maybe there is something there? So those are some of the things, but viewing the decisions as trade-offs, it's a mindset thing. If you believe it's optimized, there's always going to be trade-offs. If you believe there's abundant opportunity, there is. You just have to go find it. So the second barrier, over relying on benchmarks to other projects. So for this one, I'm not bashing benchmarks. They have value. There's a reason to use them. There's a place to use them. You can leverage wisdom. They bring value. What I'm talking about is when they become overused and people turn off their analytical, capabilities and start copying and pasting just for the sake of copying and pasting and saving money during engineering. The challenge is that it hides opportunity. So here's an example. What I'm going to use is the access roads to the well pads. And I'm going to talk about their width. What's the minimum width for an access road? And this was originally set based on comparing to company technical standards used on a past project. Basically, they benchmarked the road width saying, hey, last time we built roads for this project, here's the standard we used. We're going to use that same standard. We don't need to look it up again. We're good to go. What that standard said is you need to be able to have two vehicles traveling in opposite directions, and they must be able to pass each other, and the standard dictated what the specified buffers were between the vehicles, and so you had a width. Turns out, though, when you dig in, that particular standard was written for full-size trucks moving at highway speed. And so while it's a great standard for trucks on a highway, these were well pad access roads where you might be taking a quad out there. Like the biggest thing you'd be taking out there is a pickup truck. And so when you apply an updated standard, rather than just taking the benchmark to the last project, which happened to be a chemical plant they had built, it was, hey, let's take a look at what's the standard for an access road where all you have the biggest thing on there is going to be, say, a pickup truck or an emergency access that actually had the same dimensions, mirror to mirror. And what would that be? And in this case, you were able to reduce the road width by 25% by getting rid of the benchmark and using a better standard. So how do you get at going after benchmarks? It's a gut check again. I'm going to say the word mindsets many times, because anytime we're doing an improvement, basically half the battle is the analytical figuring out what is, technically the best design. The other half of the battle is always stretching each other's mindsets on what's possible, what can be done. So a gut check. If a team doesn't understand exactly where a standard came from and why that standard is the standard, it's very likely not adding full value. Also, the process for healthily challenging. We're not saying change everything, but the process to visit a standard and say, hey, why are we using this one? What if there's a better one to be used? There should be a straightforward process for doing that, or performing a derogation if it's called for. On a project, that should be a well-oiled process. And then just recognize every project has unique attributes. We always say the same capital project will never be built twice in the same location, same time, same condition, same team. Recognize every project is unique. Leverage the past wisdom, but look for what's unique about each project to maximize its value. So the third barrier I'm going to talk about is just dismissing ideas prematurely, thinking they're not worth much. And the challenge here is that on a big project, the value measure is usually not straightforward, honestly. Oftentimes it's an NPV or an internal rate of return or some combination of those. And what projects have done, best practice over the years, and at this point it's just commonplace, is you have a project controls organization with very specialized roles that promote the estimate quality and accuracy and promote all the financial calculations, which is a great strength to have. The challenge is then your frontline engineers or frontline designers are often a step removed or become out of touch of just exactly how their decisions are impacting the overall economics of a project. So how this came up on the well pad project is, the example I'll use here is the pipe racks between the pads into the central processing facility. Basically, there's a sketch mock-up of one, but basically when the project at this point in design basis was engaged, the pipe rack design was all but finalized. They had already done tons of studies. There's a bunch of factors I've got listed on the screen. Basically, the mentality, it came back to the iron triangle, but the mentality was, hey, we can change any of these. We could change the metallurgy, but it's going to cost us in reliability and OpEx. This design is as good as we're going to get. We've already done an extensive study. So the example I'm going to use here is just on the insulation study on what insulation material was the most cost effective for this project as far as reliability, serviceability, constructability. They were looking at the full lifetime cost. And yeah, it was a really solid evaluation. So the thought was, hey, we've already looked at the insulation, don't bother, there's no value there, there's nothing, let's move on to the next thing. That was true until someone asked, hey, I know that the study looked at all the different materials of insulation. How many different scenarios did it run on thickness, though? And then it was, whoa. Yeah, the study just assumed this thickness per this standard, and that's the thickness, we use, and basically it was an analog. Each different material had its own preset thickness, and we found the cheapest one. It's like, okay, well, we agree that is the best material for this, but let's update the study and now run thickness scenario and tell me what's the minimum acceptable thickness that meets all our needs. And so in this case, the team was able to drive a 50% reduction in thickness, still using the same material. But that's an example where the team thought there was no value looking at the insulation, but there still was an unaddressed value driver there that was hiding significant value. So how do you get at this, not just dismissing ideas because, hey, we did a study, we're good. The first thing is I use the insulation example because it was so straightforward to the team to know, hey, if your insulation's half as thick, it's going to cost a bunch less. Not every design decision's that straightforward, especially if you're talking about, say, automation, where there's a CapEx versus OpEx trade-off, things like that. So what every team needs is a single primary metric for how they define value. And that has to be, call it, maybe it's IRR, maybe it's NPV, maybe it's CapEx equivalent, but there should be an agreed upon objective, straightforward measure for the project. Then from there, it's about building sensitivity. So something we do on basically every project that has a complex value measure is build what's $1 in OpEx worth in terms of CapEx, what's 1 month earlier delivery, basically 1 month reduction on the schedule worth in terms of CapEx and OpEx, so that we can very straightforward translate between these value sources. And then project team members need to have access to this so that before any idea is dismissed, at least you can do the 5-minute ballpark on it. You know, is it potentially worth 1 million or is it potentially worth 10 million? There's a difference. But team members can do that really quickly and not dismiss ideas prematurely.